Hello everyone, in this video lecture we are going to study about bending of a cyclist. When a cyclist negotiates a curve, he bends slightly from his vertical positions towards the inner side of the curve, means he bends towards the inner side of the curved rod. To take a safe turn, the cyclist need a minimum speed, and in this video lecture we are going to find the value of that minimum speed. If the speed exceeds then minimum speed, then the cyclist does not able to take the safe turn. So when a cyclist take a turn, then various forces act on the cyclist are: first one is due to his weight a force act downward, that is mg. Second one is normal reaction offered by the rod to the system and at an angle theta with the vertical. Let us assume that the force of friction between the tire of a bicycle and the surface is negligible. Now we are going to resolve this normal reaction force into two components. First one is r cos theta, which is equal and opposite to the weight of the system. Here you can see r cos theta act vertically upward, and a force due to weight, that is mg, act downward. This is the vertical component of normal reaction. Now another components r cos theta, which is directed towards the center of the circular path and provide necessary centripetal force to the system to remain in the circular path. The various forces acting on the system, that is cycle and man, are: first one weight wmg vertically downward, second one normal reactions offered by the rod to the system and acts at an angle theta with the vertical. It is assumed that force of friction between the tire of a bicycle and the surface is negligible. Now in the next step, resolves are in two components. First component is r cos theta and it is opposite to the mg. So here first one is r cos theta, which is equal and opposite to the weight of the system, that is r cos theta equal to mg, and second one is r sin theta, which is directed toward the center of the circular path and provide necessary centripetal force to the system to remain in the circular path, that is r sin theta equal to mv square upon r. We know that the relation for centripetal force is mv square upon r, where mv the mass, v is the velocity, and r is the radius of the circular path. Now this is equation number 1 and this is 2. Now divide equation 2 by 1, we get r sin theta over r cos theta equal to mv square upon r over mg. So this is equal to m cancel with m, we have left with v square upon rg. Here r cancel with r. We know that sin theta over cos theta, that is tan theta, equal to v square upon rg. Now rearrange this by cross multiplying. Here we get v square is equal to rg tan theta, and this implies taking square to this side, it becomes square root. So v is equal to square root of rg tan theta. So this is the value of minimum speed to negotiate a safe turn by the cyclist. Now if we rearrange from here, we get the value of theta. So theta is equal to tan inverse v square upon rg. From here you can see clearly theta depends upon v, that is velocity, and r, radius of a circular path. From this relation you can see for safe turn theta should be small theta will be small if V is small and R is large. Thus turning of the cycle should be at slow speed and along a track of large radius.